pH indicators. Color change with pH indicators are fascinating substances that help us identify whether a solution is acidic or basic simply by changing color. What are indicators? Indicators are special substances that change color depending on whether they are in an acidic or basic solution. Think of them as chemical detectives that reveal the nature of a solution through their color transformation. How do indicators work? In acids, indicator molecules react with hydrogen ions, written as H+, and this reaction causes the molecules to change their structure. In bases, indicator molecules react with hydroxide ions, written as OH-, which also changes their molecular structure. These structural changes are what cause the visible color changes we observe. Litmus paper is the most common pH indicator. It is extracted from lichens, which are organisms formed by algae and fungi living together. Litmus paper turns red when placed in an acidic solution and turns blue when placed in a basic solution. This simple color change makes it an easy and popular testing tool. Universal indicator is more sophisticated than litmus paper because it shows a full range of colors to indicate different pH values. At pH 1 to 2, it appears red. At pH 3 to 4, it turns orange. At pH 5 to 6, it becomes yellow. At pH 7, which is neutral, it shows green. At pH 8 to 9, it turns blue. At pH 10 to 12, it appears purple. And at pH 13 to 14, it becomes dark purple or violet. This rainbow of colors allows us to estimate the exact pH value of a solution. Phenolphthalein is another important indicator with a unique property. In acidic solutions with pH less than 8.3, phenolphthalein remains completely colorless. However, in basic solutions with pH greater than 10, it turns bright pink. This dramatic color change from colorless to pink makes phenolphthalein particularly useful in laboratory experiments. Methyl orange is an indicator that works best in detecting acids. In acidic solutions with pH less than 3.1, methyl orange appears red. In basic solutions with pH greater than 4.4, it turns yellow. This red to yellow transition helps chemists identify the acidity level of various solutions. Not all indicators are synthetic chemicals made in laboratories. Many natural indicators are found in plants and vegetables around us. Turmeric, commonly used as a spice, changes color in the presence of bases. Red cabbage juice displays different colors at different pH levels. Beet juice also acts as a natural indicator. These natural substances contain compounds that respond to pH changes, making them excellent alternatives to chemical indicators.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.